This is the rest of lesson 4.3, and I'm at the factor theorem, and it says the binomial x minus r being the root, is a factor of the polynomial p of x if and only if p of r is equal to 0. If we put in the root in our function and we get 0, then it is a root. Okay, so it's kind of like the remainder theorem. If you put in the root and you into the function and you get 0, then it is a factor or a root. Okay, example 2 says use the remainder theorem to find the remainder when 2x to the third minus 3x squared plus x is divided by -1. So we're going to plug in a positive 1 into the equation. So we're going to find f of x, where we're going to plug in 1. And the reason why we're plugging in 1 is because x minus 1 equals 0. X is 1. So we're going to plug in 1 in there. So I have 2, 1 cubed minus 3x, and x being 1 squared plus 1. And so we're going to evaluate this for 1. So we get 2 minus 3 plus 1, and notice that is going to be 0. And so explain, state whether the binomial is a factor. Yes, it's a factor. And that's because f of 1 is equal to 0. Okay, the depressed polynomial. A depressed polynomial is when a polynomial is divided by one of its binomial factors, and the quotient is called a depressed polynomial. The depressed polynomial has a degree less than the original polynomial. So let's see this. An example would be in the one we worked earlier, which I'm going to go ahead and review it for us, or actually on this problem right here, it's this one. If I bring down the factors of that problem that we just worked, okay, the one that's in example 2, if I bring down the coefficients, I'm going to have a 2, a -3, a 1, and a 0 is going to hold that spot that has the constant. And if I do the synthetic division with 1, I bring down the 2. 1 times 2 is 2. So I get a -1. 1 times -1 is -1. Notice I get a 0 here. And then 1 times 0 is 0. This is a depressed polynomial. I'm going to write it like this. X, and notice it's 1 power less than my original problem. My original problem was to the third power. So it's 2x to the second, dropping it down a power, minus x. Okay, that is a depressed polynomial. And you can either factor a depressed polynomial down further or whatever. Okay, example 5. It says determine the binomial factors of this equation. Okay, there's two different ways of doing this. You can use method 1, which is use synthetic division, and then you could do method 2, which is using the factor theorem. So we're going to trial and error these. That's the equation. And so if I do synthetic division on that, I'm going to have a 1, 0, -7, and 6. And so I am going to try some different factors. Now I'm going to do a condensed version of the synthetic division. and I'm going to try some factors. I'm going to try negative 4, and I bring down the 1, I get negative 4 times 1, which is negative 4, plus 0. Negative 4 times 4 is 16. That's a negative 16. That's going to give me a negative negative 16. I think I messed up right here. This should be a negative. It's a negative. You just can't tell. So negative and negative, that's a positive 16. So that's going to give me a positive 9. And negative 4 times 9 is 36. So that's negative 36. So negative 36 from 6 is negative 30. Notice this is not a factor. Okay, I don't get 0. I want to try a different one. I'll try negative 3. Bring down the 1. Negative 3 times 1 is negative 3. Negative 3 times negative 3 is a positive 9. So a positive 9 minus 7 is a positive 2. And then a negative 3 times 6 is a negative 6. Negative 6 plus 6 is 0. So notice that is a factor. So right there we know that negative 3 is a factor. Now I can continue this on and trying negative 2, negative 1, 0, 1, and 2. And I can find the factors. So x plus 3 is a factor. And so I can find the factors of the equation. Now that's one method. Another method that we could do is, we know that one root works. We can use that negative 3, and then we can find the depressed polynomial and factor it. So let me erase what I did here so I can make room to show you that. So what I'm saying is, you could put this in your calculator, find one root. Whether it's, we already know negative 3 works, but we would look at this graph and we would find a root. Let's say that we found the root was 1. So we get 1, 0, negative 7, and 6. And I could have tried 3. I know 3 works. So whenever I do the synthetic division, I bring down the 1. 1 times 1 is 1. That gives me another 1. 1 times 1 is 1. That gives me a negative 6. And then 1 times negative 6 is 0. That is a depressed polynomial. And it represents x squared plus 1 minus 6 with no remainder. That is a depressed polynomial. I can factor that. Using either quadratic, completing the square, or factoring. I can factor that. And notice I would get 3 and 2. 2 is going to be a negative because the signs are different. The bigger one needs to be positive. So there you go. So I know one factor, which is 1, and another factor is negative 3, and another one is positive 2. Now, the directions say determine the binomial factors, so that means I write them like this. Okay, so I'm going to go ahead and for sake of room, I'm going to erase again. So instead of writing that answer like that, I need to write them as binomial factors. So I'm going to write x minus 1 for that first factor, x plus 3, and x minus 2. And that would be me writing them as binomial factors. Okay, the last example is example 6. And it says find the value of k so that the remainder of, and then they give you the equation divided by x plus 3 equals 0. This is pretty easy. We're going to find out what that k has to be to have a remainder of 0. So we're going to plug in 3. And actually we're going to plug in -3 because of this right here. That's equal to -3. So I want to plug in -3. -3 to the third power plus 3, -3 to the second power minus k. I don't know what k is. That's what we're going to find. -3, everywhere I have an x, I put in a -3, minus 24. Now I've kind of run out of room, but I would set that equal to 0 because of this. Okay, the problem says that if I plug in that -3, I'm going to get a remainder of 0. So that should come out to 0. So -3 to the third power is -27. And then -3 squared is 9, and 3 times 9 is 27. So I have a -27. Sorry, my pen's not working right. -27 plus 27. And then minus k plus minus times a -3 is a positive 3k. Positive 3k. Then minus 24 equals 0. So I want to get k by itself so I can find out what k is. This goes out, and now add over 24. So 3k is equal to 24, and I divide by 3, and so k is equal to 8. And I can check that and see if it works. I can plug it back in and see if I put in k, if I get -3. So that's how I can check that. So I solve for k. Okay, here are your problem numbers. I already gave you your day 1 problems. On day 1, it's 1 through 2, 5 through 8, and 14 through 16. Okay, day 2 is going to be 9 through 13, 20 through 23, 26 through 28, 29 through 31, 34, 37 through 40, 41, 44, 46 and 47, and 53. Let's look at these quickly. Turn to your book to page 226 and look at 9 through 13. 9 through 13 is to determine the binomial factors. Remember, when it says binomial factors, you write it like this. That's how you would write it and ask for binomial factors. It would look like that. Okay? And then 20 through 23 is use the remainder theorem. So you're going to plug in the factor, and if you get 0, then it's a factor, yes, and if you don't get 0, then it would be a no. Be sure and state the remainder. Number 29, it says determine the binomial factors. Now, your first one, you might have to use your calculator or the remainder theorem to find your first one, or maybe do synthetic division to find your first one. But once you find the first one, then you can take your depressed polynomial to find the other factors. So on 29, through 31, you're going to have to either use your calculator to help you find one factor or something else. Your calculator, you could do the remainder theorem, you could do synthetic division, try some different options, and then once you find one, then you can take your depressed polynomial and factor using quadratic or by factoring. 37 through 40, those are the ones where you solve for k, like the last example. And then 41, 44, 46, 44, 41 and 44 are like applications. And then 46, 47 are mixed review. And then 53 is a SAT, ACT practice problem. All right, well, I hope that helps.